Now this is very important. Exact differential equation. Exact differential equation. So let us consider a function u as a function of xy has continuous partial derivative, has its derivatives, has continuous partial derivatives, then its differential is given by differential du is given by del u del x dx del u del y dy. Function u has continuous partial derivative, then we can write the differential of function u as du. Now there is, if u x y is some constant, then du will be 0. So we can write del u del x dx plus del u del y dy. This should be 0. If uxy is constant, so we can write equation in this form. Now, a differential equation of the form m xy dx plus n xy dy is equal to 0 is an exact differential equation, if the left hand side, if the form, let's say if the form m dx plus n dy is exact, that is, it can be written as differential of some function uxy. So if this m dx plus n dy can be written as differential of some function uxy. So if you compare this equation with this particular equation, let's say, let's compare with this equation. You can write, let's say, this is, I'm writing, let's take it as 2 equation, equation 2. So from 1 and 2, M can be written as del u del x and N can be written as del u del y. Now, del m del y, this will be given by del 2u del y del x, and what is del n del x? Let's find this value. So del n del x is del x del y. So this will give you del m del y is del n del x. This is the condition for exact differential equation. Condition for exact differential equation. So this particular differential equation is an exact differential equation if you can verify that partial derivative of m with respect to y is same as partial derivative of n with respect to x. So if it is exact differential equation, then we have to find the solution. So solution can be expressed as uxy is equal to constant. We have to find that function, and that function can be expressed as uxy is constant. So how to find the solution? So let's use this equation. For solution, how to find the solution of differential equation? So first, I will use this equation, m del u del x. There are two methods. So if you find u, you have to integrate with respect to x, taking y constant. So I am taking this integration constant to be function of y, because this is partial derivative of u with respect to x. So if you integrate with respect to x, you have to assume y is constant, and then from n is equal to del u by del y, find dk by dy and solve it. To find ky. This is the method. So you will get u, but you have to find integration constant k, that is function of y. So put n is equal to del u by del y, you will get dk by dy. And if you solve it, you will get the constant ky. And second method is, if you take n is equal to del u del y, this will also give you the solution. So u is given by integral n dy. Now integration constant is function of x. This will be function of x. Now you have to use from m is equal to del u del x, find dl by dx and solve it to find lx. So either you use method 1 or method 2, both will give you u, and then finally your solution you have to write in this form. Uxy is some constant c. This will be the solution. If this is an exact differential equation, your final solution can be expressed in this form. Uxy is some constant c. ठीक है? So let's take some example based on exact differential equation. So this is x cube plus 3xy square dx plus 3x square y plus y cube dy is equal to 0. Find the solution of this differential equation. X cube plus 3xy square plus 3x square y plus y cube. So here m is x cube plus 3xy square. What about n? 3x square y plus y cube. So you have to find what is del m by del y. So this is 6xy, and that is same as del n del x. Just take 6xy, take partial derivative with respect to x or y, taking other constant. So this satisfies the condition of exactness. Del m del y is del n del x. So now it's a exact differential equation. So this is a exact differential equation. So what will be the solution? Let's see case 1. I am using the case 1. M is equal to, what you will take? M is equal to del u del x. So this will give you u is integral m dx plus ky. So this is m is given by x cube plus 3xy square dx plus ky. So u is given by x power 4 by 4 plus 3 x square y square by 2 plus ky. Now you know that n is equal to del u del y. So this will give you 3x square y plus y cube, and take derivative with respect to y. So this will be 0 plus this is 3x square y plus d. This is the ordinary derivative with respect to y because it is function of one independent variable. So this is dk by dy. And if you equate both sides, this will cancel out. So you will get dk by dy is y cube. So dk by dy is y cube. So what will be k as a function of y? y power 4 by 4 plus some new integration constant c dash, because now it's an ordinary derivative, dk by dy. So integrate with respect to y and you will get a integration constant. Integrate this. So this is y power 4 by 4 plus some constant. So what will be u here? Now u as a function of x, y, this will be given by x power 4 by 4 plus ky y power 4 by 4 plus 3 by 2 x square plus y square plus some constant c dash. ठीक है? Now your final solution will be given by, our solution is uxy is some constant. So I'm absorbing this constant c. So that will be given by, this will be, let's take x power 4 by 4 plus y power 4 by 4, 3 by 2 x square y square, and this will be some constant c. This is the solution. This will be the solution. Second method is to find u, that is n is equal to del u del y. So this will give you u is equal to n dy plus integration constant Lx. So this will be, n is given by 3x square y plus y cube dy plus Lx. So this will be 3 by 2 x square y square y power 4 by 4, this value. Again, since m is del u del x, so this will give you x cube plus 3xy square, and del u del x is again, this will be 3xy square plus 0 dl by dx. So this will cancel out, and dl by dx is x cube. Lx is x power 4 by 4 plus some constant c dash. So again uxy is, you have 3 by 2 x square y square y power 4 by 4 plus x power 4 by 4 plus some constant c dash. And final solution is uxy is some constant. So this will give you x power 4 plus y power 4, 3 by 2 x square plus y square this should be constant C. So both method will give you same result. So either you can use this method or this method. So normally we try to calculate from first method. ठीक है? Let's take another example. So sin x cos hyperbolic y, sin x cos hyperbolic y dx minus cos x sin hyperbolic y dy is equal to 0. And it is given that y at x is equal to 0 is 3. So you will get the constant also. So here m is sin x cos hyperbolic y, and n is minus cos x sin hyperbolic y. And you know that what is cos hyperbolic y? E power y plus e power minus y by 2, and sin hyperbolic y is e power y minus of e power minus y by 2. So this will be del m del y. So cos will give you sine. Derivative of cos hyperbolic is sine hyperbolic. And just see, this will be del n del x. Because cos x is minus sine x. So this is an exact differential equation. This is an exact differential equation. So I will use first method. So what will be u? U is given by integral m dx plus ky. So u is given by sin x cos hyperbolic y dx plus ky. So sin x will give you minus cos x. So this will give you, u will be given by minus of cos x cos hyperbolic y plus ky. Now we will use, since n is equal to del u del y, so this is minus cos x sin hyperbolic y sin hyperbolic y, and then you have del u del y is minus cos x sin hyperbolic y plus dk by dy. So this will cancel out, and dk by dy is 0. So k is some constant value. K is some constant value. So uxy is minus cos x cos hyperbolic y plus c dels. And then final solution is uxy is constant, uxy is some constant. So I will absorb the negative sign also, and let's write this to be cos x cos hyperbolic y is equal to some constant c. This is the value. When x is equal to 0, so what will be cos hyperbolic 3? Let's calculate cos hyperbolic 3. So e power 3 plus e power minus 3 by 2. And if you calculate this value, so this value is given by 10 point, just check this value, 10.07. So from this equation, y0 is 3, you will get cos 0, and this is cos hyperbolic 3, cos you have cos hyperbolic 3 is equal to c. So c will be 10.07. So final solution will be cos x cos hyperbolic y is equal to 10.06. So this will be the solution of exact differential equation, and we have calculated the constant c also, and that is 10.07. So now we will talk about non-exact differential equation, how to solve non-exact. So this is equation reducible to exact form. Equation reducible to exact form. So let p dx plus q dy is equal to 0 is a non-exact differential equation, is a non-exact differential equation. That is del p del y is not equal to del q del x. If del p del y is equal to del q del x, that will be exact. So in short, we write it as py is not equal to qx. This is how we represent the partial derivative. So if our differential equation is non-exact, we can convert that non-exact differential equation into exact differential equation. So for that, you have to multiply this equation by some integrating factor. So let us multiply equation 1 by integrating factor f. F is in general it is function of xy. then 1 becomes exact. If you multiply non-exact differential equation by some integrating factor, it becomes a exact differential equation. So let's see, fp dx is fq dy, and this is an exact differential. I am assuming it's an exact differential equation. So you have to compare with m dx and dy. If this is exact, so equation is m dx and dy, and what will be the condition? Del m del y, del m del y is del n del x. So this will give you fyp plus fpy is equal to fxq plus fqx. I have assumed that if you multiply this equation by some integrating factor, it becomes exact. So we have applied the condition for exact differential. Now for simplicity, we will consider our integrating factor to be either function of x or it is function of y. So first, let f to be function of x only. So when it is function of x, what will happen? Fy will be 0 and this fx will be f dash, that is df by dx, that becomes an ordinary derivative. So let's use this condition. Put fy is equal to 0. So this implies if fy is 0, so you will get f py is equal to fx is df by dx into q plus f qx. So this will be f times py minus qx, and this will be q times df by dx. Now we will write 1 by f df by dx. This is 1 by q. Py is, this is py minus of qx. And let's say this is function of rx. This will be function of rx. So if you solve this equation, so Rx, our integrating factor Fx is expressed as Rx dx. This will be the integrating factor. In same way, if you assume f to be function of y, then fx will be 0, fy will be df by dy, and this will be given by df dy into p plus fpy 0 plus fqx. So this will give you df fy is df dy into p, and that will be f qx minus py. And you can write this equation as 1 by f df by dy. This is 1 by p qx minus py. 1 by p qx minus py. So this will be function of y. So if you solve it, now integrating factor fy is given by ry. So we have to find integrating factor. Normally you will see, we will try this one, and you will get fx in some simple form, and then multiply with this, you will get a exact differential. If fx is complicated, then you can also try for fy. So normally from fx you will get the result. So we will take either fx as the integrating factor or fy as a integrating factor. ठीक है, एग्जाम्पल करें. So let's take first example. Equation reducible to exact form. So equation is minus y dx plus x dy is 0. We have to solve this differential equation. And this is non-exact because you can check, if I take p to be minus y and q is x, so what is py is minus 1 and qx is 1. So py is not equal to qx. So this is the non-exact differential equation. Now we have to multiply this equation by an integrating factor. So let this rx is given by 1 by q. What 1 by q py minus qx. So q is 1 by x, py is minus 1 and qx is minus 1. So this is minus 2 by x. So what will be integrating factor? Integrating factor is integral rx dx. So this is minus 2 by x dx e power minus 2 ln x e power ln x power minus 2. So this will be 1 by x square. So this is the integrating factor. So multiply 1 by x square. So this will give you minus y by x square plus 1 by x dy is, this will be minus y by x square dx plus x 1 by x dy is equal to 0. And this is an exact differential equation. This is an exact differential equation. You can check that m is equal to minus y by x square, n is equal to 1 by x. So del m del y is minus 1 by x square, and that is del n del x. So it's a exact differential equation. So solution is given by, I am using m dx plus ky. So m is minus y by x square dx plus ky. So this is y by x. 1 by x square will give you minus 1 by x. So this is y by x plus ky. Now since n is equal to del u del y, so n is 1 by x. So 1 by x del u del y is 1 by x dk dy. This will give you dk dy is 0. Or ky will be some constant c dash. So u as a function of xy is y by x plus c dash. Final solution is uxy some constant. Let's absorb constant c dash. So it is given by y by x is c. So this is the solution of differential equation, that is non-exact differential equation. Y by x is c. ठीक है? So next example, 2 sin y square, 2 sin y square dx plus xy cos y square dy is equal to 0. And it is given that y at x is equal to 2 is under root pi by. You have to solve this differential equation. So let this first term is p. So this is 2 sine of y square. Q is xy cos of y square. So py will be given by cos y square plus 2y. So that will be 4y cos y square and that should be equal to And what will be qx? And what will be qx? Y cos y. So it means py is not equal to qx. So it's a non-exact differential equation. This is a non-exact differential equation. So we want to convert this equation into exact. So you have to multiply with the integrating factor. So we will first find Rx. Rx is given by 1 by q py minus qx. Use this formula. So that will be given by 1 by xy cos y square. Py is 4y cos y square minus of y cos y square. So y cos y square will cancel out. You will get 3 by x. This value is 3 by x. So integrating factor fx is given by rx dx. So integral 3 by x dx, 3 ln x. So fx is e power ln x cube, and that will give you x. Now multiply equation 1 by integrating factor. Multiply equation 1 by x cube. So that becomes twice x cube sine of y square plus this is dx plus x power 4 y cos of y square dy, and that is 0. So this becomes a exact differential. This is a exact differential equation. Now take m to be twice x cube sine of y square. N will be x power 4 y cos of y square. So what will be del m by del y? So this will give you cos y square into 2y. So 4 x cube y cos y square. And that should be equal to del n by del x. So because this will again give you 4x cube y cos y square. So this is a exact differential because this condition will satisfy. So solution will be given by u is m dx plus ky. M will be twice x cube sine of y square dx plus of ky. So this will give you twice x power 4 by 4 sine y square plus ky. So, and this value is 1 by 2 x power 4 sine of y square ky. Now, since n is del u del y, so n is given by x power 4 y cos of y square, and that is del u by del y. This will give you cos y square into 2y. So that will give you same value, x power 4 y cos y square plus dk by dy. This will cancel out. So dk dy is 0. K is c dash. So finally solution is uxy is constant. So we can write this will give you 1 by 2 x power 4 sine y square is, this is the solution. One by 2 x power 4 sine y square. I have absorbed this constant c, and it is given that at x is equal to 2, y is root pi by 2. So use this condition. 1 by 2 x is equal to 2 sine y square is pi by 2. This is c. So c will give you 8. So finally you will get x power 4 by 2 sine of y square, this is 8, or we can write x power 4 sine y square is 60. This is the final answer. X power 4 sine y square is 16. So this will be the solution. ठीक है. So one last example. So this is 1 plus y square dx plus xy dy is 0. Let's solve this differential equation. So take p is 1 plus y square, q is xy. So py is 2y and qx is y. Py is not equal to Qx. So this is non-exact. So you have to find, for integrating factor, find Rx 1 by Q Py minus Qx. So 1 by Q is 1 by xy and Qx is minus y. So that will give you 1 by x. So integrating factor is Rx dx. So this will be e power ln x. So integrating factor is x. This value is fx. This is integrating factor. Now multiply equation 1 by integrating factor. So if you multiply by x, what you will get? This value is x 1 plus y square dx plus x square y dy is 0. So this is an exact differential equation. Now take m to be x1 plus y square and n is x square y. So what will be del m del y? So this is 2xy and that should be equal to del n del x. So equation becomes an exact differential equation. Now for solution, we will use this equation m dx plus some integration constant. M is x 1 plus y square dx plus ky. So u is given by x square 1 plus y square by 2 plus ky. Now since n is equal to del u del y, so n is x square y and del u del y will give you simply x square y because first term will be 0. Second is 2x square y, 2 will cancel out. So this is x square y plus dk by dy. This will cancel out. So dk by dy is 0. So k will be constant c dash. So again, uxy is some constant. This will be the solution. So you can write x square 1 plus y square by 2 is constant. This will be the solution. So x square 1 plus y square by 2 is equal to c. So this is the solution of given differential equation.